Hi everyone, today we are going to solve Leetcode's valid palindrome problem. Let's look at the problem statement. A phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. Given a string S, return true if it's a palindrome or false otherwise. So if here we have the input S is equal to a man, a plan, a canal, Panama, and output is true because when we remove all the white space, comma, and colon, we have a palindrome, a man, a plan. So we can read it from backwards. And here the input is race a car, but this is not a palindrome because when we read from backwards, R, A, C, this should be E, not A. And yes is an empty string after removing the non-alphanumeric characters. So since empty string reads the same forward and backward, it is a palindrome. And here we have some constraints there. And let's look at the code. Let's start coding, and first we can talk about possible approaches and we can code for each approach that we could think about. Okay, so so basically for this problem we need to process the string. We need to convert the uppercase letters to lowercase letters and remove or ignore non-alphanumeric characters like spaces, commas, colons, and use character dot is letter or digit. We can use that to identify alphanumeric characters. And then we need to check for palindrome, compare characters from both ends to ensure they match, and we can handle edge cases like empty strings or strings with only non-alphanumeric characters. So we are going to explore three approaches here. The first one is going to be pre-process string and check palindrome. Here we are going to build a new string with only lowercase alphanumeric characters and check if it's a palindrome. And the second approach is going to be two pointer in place. Here we are going to use two pointers to traverse the string in place, skipping non-alphanumeric characters. And the third is going to be regular expression and string reversal. We can use registers to pre-process the string and check palindrome via reversal or two pointers. So let's look at approach 1, which is pre-process string and check palindrome. Here the idea is to create a new string containing only lowercase alphanumeric characters and check if the new string is a palindrome using two pointers. The space complexity here is going to be O of n due to the new string, and the time complexity is going to be O of n for pre-processing and O of n for palindrome check. So totally O of n, and it's going to create, because it creates an unnecessary copy, it's less efficient than in place methods. So the steps here are, first step would be initialize a string builder to store lowercase alphanumeric characters. Then the second step would be iterate through yes. For each character, if character.is letter or digit returns true, then append its lowercase version character.to lowercase and convert the string builder to a string. Use two pointers to check if the process string is a palindrome. We can compare characters from both ends. If they differ, we return false, and if the loop completes, we return true. So I'm going to write the code here. So step 1, the first step is going to be pre-process the string. We are going to use a string builder here. String builder filtered. The step 2 is going to be checking the palindrome, checking with two pointers. Okay, let me run this code. I'm going to submit and see what's happening to see the performance. Okay, it's good. It's 3 minutes and beats 73 percentage, and memory beats 58 percentage of submission. That's good. Okay, now let me give an explanation here. Here I'm creating a string builder filtered to build the process string, and we are iterating through yes, and for each character C we are checking if the character is letter or digit, and it returns true for letters A to Z, lowercase, uppercase, or digits 0 to 9, and it returns false for spaces, punctuations, etc. So if true, append character dot lowercase of the character to filtered, and here we are checking, and then we are converting the filter to string processed, and here we are checking if the palindrome with 2 pointers. So we are initializing the left pointer as 0 and right as processed minus the length of the processed minus 1, and while left is less than right, we compare process.caret left and process.caret right, and if process.caret left is not equal to process.caret right, we are returning false, and then we are incrementing left and decrementing right, and we are returning true if the loop completes, there are no mismatches, and the edge cases here are empty or non-alphanumeric. Processed is empty, then so in that case process is going to be empty. Then for if when left is greater than or equal to right, it returns true, and it's handled, and in case we have mixed case, it's handled by two lower because it's handled here because we are converting into two lowercase. And the space complexity, time complexity here is for pre-processing. It's O of n to iterate through s with character dot s, letter or digit, and two lowercase being O of 1. And palindrome check, it's O of n for 2-pointer traversal. So totally it's O of n. And for space complexity, it's gonna be we are using string builder and string for string builder filtered, and for string processed, it's going to be O of n for storing the processed string, and temporary variables O of 1, so it's totally is going to be O of n. So now let's have an example walkthrough. So I'm going to copy this example from here. So we have a string builder filtered, and we are iterating through yes, and so first we have yay, and it's okay, I'm just gonna write it here. So first we have yay, and yay is a character. Is character or is letter character dot is letter or digit is going to return true. So we are going to append the lowercase of it to filtered, and then we have white space, and character is letter or digit. It's of that empty space, it's gonna return false, so we're gonna skip it. And then we have yam. So we are gonna append this. Okay, I think instead of writing here, I'll just talk about it. Yam, we are gonna append this, append, skip, skip, append, skip, append, skip, append, skip, append, skip, append, skip, skip, append, and append. So the filter is going to be yay, yam, yay, yan, yay, PLAN, a, can, no, Panama. Okay, that's what it's going to be. And it's going to convert it to string, and then we have now we are going to check if it's a palindrome with 2 pointers. So left is equal to 0 and right is going to be 20, minus 1, which is 19. And so we are checking if yay first and the last, left and the right. So we are checking if this one right here, this a is the a at 0 is it going to equal to a at 19? Yes, they both match, the left and the right. So processed dot caret left is if it's equal to or not equal to the processed or caret right, it is. And yam, am, and there's only one am actually, because a man. There's a, and here's a, and there's a yan, and here's a yan. So yes, the loop completes. And when we come here, C versus C, like it's gonna be the left is 10 and the right is equal to 9. So because left is not less than right anymore, we exit the loop. When the left is greater than or equal to right, we exit the loop and then we return true. Okay, now I'm going to talk about the nest approach, which is going to be a two pointer in place. And here the idea is to use 2 pointers, left and right, to traverse S from both ends. We are going to skip non-alphanumeric characters using character.is letter or digit and compare lowercase versions of alphanumeric characters in place. The advantages here are it's space efficient O of one space, and it's efficient single pass of n time. It handles all edge cases robustly. And the disadvantages here are it's slightly more complex due to in-place skipping logic, and it requires careful handling of character checks. And this approach is preferred because of the optimal space complexity of 1 versus O of n, and it's suitable for large inputs, and it avoids creating new strings. So here the step is going to be, we are going to initialize the left and the right pointers. Left is 0 and the right is going to be the length of the string -1, and while left is less than right, we are going to skip non-alphanumeric characters at left. That is, if character dot is letter or digit is, if it is not that, then we are going to skip it and we are going to increment left. Similarly, we are going to skip the non-alphanumeric characters at right and compare lowercase versions of s dot caret of left and s dot caret of right using character dot to lowercase, and if they differ, we return false, and then we move left forward and right backward and return true if the loop completes. Okay, let me write that code now. So first we are going to initialize 2 pointers. Int left is equal to 0. Int right is equal to s dot length as 1. Then we are going to traverse the string from both ends while left is less than right. We skip non-alphanumeric characters at left and skip non-alphanumeric characters at right. Now I'm going to compare the lowercase versions of the characters. Now we can move the pointers inward. And we return true if the loop completes and there are no mismatches. Okay, so let me run this code. So line 10. Okay, and here we can see that it's much better than the previous solution. It beats 99 percentage of the submissions, and here the memory is better too. It beats 83 percentage of the submissions. And now let me explain this a little bit. Let's go over this code. Here we are initializing the pointers, and in the loop we are traversing, we are checking if left is less than right, and skip at left if the character is letter or digit returns false, and increment left to left to skip the non-alphanumeric characters. We do the same at right too. And then decrement the right pointer, and if and then we are comparing the character at left to the character at right, and if they differ we return false, and we are moving the pointers left plus plus and right minus minus. We are incrementing the left and decrementing the right. So yeah, and that's the code, and if there are no mismatches we are returning true. The time complexity here is O of n. Each character is visited at most twice. And so the total is O of n, and space complexity is it only uses left, right, and temporary variables, no extra data structures. And okay, now let's look at the next approach, which is regular expression and string reversal. Here the idea is to use the regular expression to remove non-alphanumeric characters, and we are converting the string to lowercase, and then we are checking if the process string is a palindrome using two pointers or reversal. The space complexity is O of n for the new string, and time complexity is O of n, but regex as higher constant factors. So let's look at the code. The steps are here. First, we pre-process. We use yes dot replace all of anything other than a to z, and 0 to 9, and to remove non-alphanumeric characters. And we are converting to lowercase with two lowercase, and compare characters from both ends. If they differ, return false. If the loop completes, return true. So let me write the code here. Step 1 is going to be pre-process. Pre-process with regex. So the left is going to be 0, and right is going to be process dot length minus 1. Okay, let me run this code. Okay, let's see the time complexities. Okay, this is not very good, but the previous my previous submissions were much better than this one. And okay, so here yes dot replace all is, and we are matching any character not in a negation of A to Z, uppercase A to Z, and 0 to 9, and we are replacing it with an empty string, removing non-alphanumeric characters, and here and then we are converting to lowercase, and the result would be a processed string, which is a clean string. And then for palindrome check we are using two pointers. Left is equal to 0 and right would be process dot length minus 1, and while left is less than right, we are comparing the process dot caret left. If it's not equal to the process dot caret right, if a mismatch occurs, we are returning false. And we are incrementing the left pointer, decrementing the right pointer, and then when the loop completes, if there are no mismatches, we are returning true. And this approach is very concise, and but the disadvantage here is that it has a regex overhead, and which could require some extra spaces. And okay, see you in the next video.